Hi, this is Dan continuing with the GMAT Advanced Quant series. If k is the sum of the reciprocals of the consecutive integers from 41 to 60 inclusive, which of the following is less than k? A quarter, a third, or a half, and we have 5 multiple choices. So let's think about this. K is the sum of the reciprocals of consecutive integers from 41 to 60. So basically what they're saying is that k is 1 over 41 plus 1 over 42 plus ... all the way up to 1 over 60. And actually, if I wanted to write these in order from smallest to largest, I should write 1 over 60 first and have it go up to 1 over 41. But either way, commutative property of addition, so it doesn't matter how we write it. That's the sum that we're talking about. That's what k is. And they want to know which of the following is less than k. So how can we approximate the value of k? Let's take a look at the multiple choice. I think it's interesting to realize our choices. A is none, which is to say that k is smaller than any of these. 1 only, which means it's that a quarter is less than k, which is totally possible. 2 only, which means that a third is less than k. But if a third is less than k, then certainly a quarter is less than k, because a quarter is less than a third. So that's actually impossible. So right away we can eliminate C. We haven't done any work yet, except look at the choices. 1 and 2, that's totally possible. That's saying that a quarter and a third are less than k, but a half is not. And E, they're all smaller, so k is greater than a half. So what's cool about that is now you've eliminated one of the choices. It's actually worth it to guess now. Even if you had no idea, you've now swung the probability in your favor. And if you had no idea what to do, you could take a random guess and probability would be on your side that you have a slightly better chance, or that if you guess in enough situations where you've eliminated one choice, you'll earn more points than not. So it's worth it in the long run. Anyway, let's actually sharpen our pencils and see what we can figure out based on this sum. So I'd like to consider the extremes. What's the biggest k could be? Is it possible that k could be bigger than all these and that E could be the best answer choice? Well, let's imagine that instead of having this variety of terms, that they were all as big as the biggest term. So the biggest term is 1 over 41, and there are 20 terms going from 41 to 20. So if you have 1 over 41 and you had that 20 times, then you're choosing the biggest one, so this method will overstate the value of k. So let's just realize that, but what would it be? It would be 20 over 41. 20 over 41 overstates the value of k. K is actually not quite this big. K is smaller than this. But this is less than a half. And k is less than that. So if this is less than a half and k is less than this, then then k must be less than a half. So a half cannot be less than k. Hopefully you followed that. So we're considering the extreme. We chose the biggest possible item in the sequence, and we imagined that all of the items were that big, and we got 20 over 41, which is less than a half. So k must be less than a half. So a half can't be less than k. Oh, sorry, I don't want to cross that out, although I could at this point. So it can't be 1, 2, and 3 because k is less than a half. Definitely. Okay, now let's consider the other extreme. What if all of the terms were as small as the smallest term? Well, the smallest term is 1 over 60. If you had 20 terms that were all as small as 1 over 60, then you would understate the value of k. So that would equal a third. But that understates the value of k because we chose the smallest item in the sequence. So in fact, k is bigger than that. K is more than a third. Because even one term bigger than 1 over 60 would make it more than a third. And so, which of the following are less than k? A third has to be less than k. If k is less than a third, then a third is less than k. And of course, a quarter is less than a third, so that's also less than k. So the best choice is D, 1 and 2.